Welcome guys, I'm Dr. Avitek. In this video, we're going to be solving this very problem. Now remember to hit the subscribe button, like this video, and share it across to your classmates. Now, the year this very question came outside, please take note, this question can actually be alternated multiple times. That is to say, that this could have been -1, 1, -2, because this came out from the University of Benin. So this very equation here can actually be alternated. You could have the one that have -1, 1, -1. But let's look at the graph, because the year this question was given, you were provided with the graph, because sometimes it actually helps if you have the graph. But let's see. Now looking at this graph, you can tell that if you already understand even and odd functions, this function is going to be an even function. But before then, let me pretend as if I have no idea about this, about what it means to be even and odd. Let me find my A0. So A0 is 1 over pi. Then we have the integral from -pi to pi, because our limit is -pi to pi. So the interval is also symmetric. That is why I can talk about even and odd function of f of x dx. But like I said, this guy you see here, this integral is the area. This is the area. So there should be an easy way for me to find my area. There should be an easy way for me to find my area. I don't want to stress myself. So there should be an easy way to find my area. Now take note that these guys below the x-axis, they're always going to be giving you a negative area, and above will be giving you a positive area. So let's start with the ones above. Now this is a rectangle. So let me say the breadth from this point to this point, this is 0 to 2, right? This is 0 to, or you can call it the height if you wish. This is 0 to 2. So we'll have height of 2. Then from here to here, from -pi to pi over 2 is pi. From -pi to pi over 2 is pi. That's the distance. Or you could say that, this is like saying that from -half to half, that's 1. Because half to, I don't want to really start stressing over it. But from -pi to pi over 2 is just pi. You can find the distance and you will be correct. So that's pi. Now, what will be the area of this? The area of this part is going to be plus 2 pi. So let me just call this as plus 2 pi. So that's the area of the top part. Now let's go to the bottom. At the bottom again, this part from here to here is still 2, because we have this as -2. So the height from this point down to this point is 2. Now how about this point to this point? This point to this point is what? Is pi, and pi over 2, sorry. Because you have pi over 2 down to pi. So the distance from pi over 2 to pi is pi over 2. So the area is to say this times this. So 2 times pi over 2 will just give you pi. Because all you have to say is to say these 2 at the bottom, we cancel the 2. So you have only pi. Because to find area is length times breadth. So 2 times pi over 2 will give you pi. So that's this. But this area is kind of negative. Now this and this are actually two similar things. That's similar. So this is also -pi. Now let's look at this. So what will be the sum of all of these areas? 2 pi minus pi minus pi. That's 0. Because at the bottom, -pi is -2 pi. So there's a -2 pi at the bottom. There's a 2 pi at the top. So this will just give us 0. That's just going to be giving us 0. So A0 is equal to 0. Now, if you wish, you can actually solve for this, but the function is looking very, very bulky. So, yeah. So that's just A0. Now, let me look for A sub n. Let's look for A sub n. So A sub n is 1 over pi. Then we have the integral from -pi to pi of f of x cos nx dx. Okay, so this is what we have. So this will become 1 over pi. Then I'm going to be saying the integral this time around. Please take note, even if this is an even function, another reason why we need to understand what even functions are is when you look at this graph, it actually looks like cosine. So an will not be 0. An will not be 0 because this graph looks like cosine. Remember that our sine graph, let me start with our sine graph. So, yeah. This is what the sine graph basically is. So this is your sine graph. 0, 1. This is your sine graph. Then this is cosine. Cosine is kind of like this. Oh no. The peak is not entering. So, yeah. So this is what cosine is. Now you can spot some similarities here. This and this. That this is a rectangle, while that one is a parabola. So you can spot it. That this is looking like cosine. That is why this function would be having a sub n. So it's even. So this function will be having a sub n. Because it looks like it. That's the idea of Fourier series. We're trying to see how much of sines and cosine are in a particular function. And in this very function, it looks exactly like cosine. So there will be cosine embedded in it. But for sine, there will be no sine. But if you wish, you can actually go and solve further. You can solve further for you to see that there will be no sine component inside that very function, because it doesn't in any way look like a sine graph. So this is what a sine graph looks like. What we are having is looking like a cosine. So that's the whole beauty of the whole thing. Let's proceed, please. So this will be the integral from minus pi to pi. Now the problem is, if you look at this function, the function that we have, there's no single value from minus pi to pi. Instead, there were different intervals. It was a piecewise function. So what we have to do is to say, we're going to break our limits. So we're going to break our limits. But the thing here is this. Since this is even, okay, I've not yet treated even an odd function. So let me know how to explain it now. So we're going to break this down. So minus pi, we're going to say minus pi to minus pi over 2. That's the first one. Then give some space. Then the next one will become minus pi over 2, minus pi over 2, so pi over 2. Give some space. The next one will then become pi over 2. Oh no, that's positive. Pi over 2 down to pi. Now, every single thing should have f of s cos nx. So what is f of x within this interval? F of s within this interval is minus 2. So we have minus 2 cos nx dx. Then over here, the interval, the value at this interval is 2. So this will be 2 cos nx dx. Then the value at this interval is minus 2 cos nx dx. Okay, let us proceed. Let us proceed. Okay. Now, like I said, there's actually an easy way to evaluate all of these integrals, but they're looking kind of bulky. Let me see if there's a way I can simplify it without going through the stress of doing them one by one. If there's no way, there is a way, but if it's something I cannot apply in this video because I've not yet treated a particular subheading, then I won't do it. But let me see. Okay. Nah. Not gonna work. So I'll just kind of do them together. I'll just do them one by one. Even though that's looking so stressful. But I'm just gonna do them one by one. But I think there's a way. I'm not just looking at it clearly. Otherwise, there should be a way. There should be a way. So let us start. This minus 2 is a constant, right? So bring it outside. So this is minus 2, integral from minus pi to minus pi over 2 of cos nx dx. The 2 here is a constant, so this is plus 2, integral from minus pi over 2 to pi over 2 of cos nx dx. Then minus 2 is a constant, then integral from pi over 2 to pi of cos nx dx. All right. Now, if you look at every single function here, 2 is common. 2 is common. So I want to bring out 2. So this is 2 over pi. And this is minus. Now, if you look at this, when you integrate cos, what would you get? If you integrate cos, you're going to have if you integrate cos, you're going to have sine. So this will be sine nx over n. Then you put in your limit, minus pi to minus pi over 2. And this is plus 2. Again, the integral of this is sine nx all over n. Then this is minus pi over 2 to pi over 2 minus 2 sine nx. The limit at this part is pi over 2 to pi. Okay, over n. Over n. Now, if you look at every single thing, oh, there will be no 2 because I've brought out 2 before. Yeah, I've brought out the 2's, so there's no 2. Next, the over n is a constant. Over n is a constant. So let's bring out the over n. So this will be 2 over n pi. Then, what will be left? What will be left to then become minus sine nx from minus pi to minus pi over 2 plus sine nx from minus pi over 2 to pi over 2 minus sine nx from pi over 2 to pi. Okay, now let us put in our limits. Let us put in our limits. We can now do that. But let's do that in a faster way. Remember that sine n pi is 0. Sine 0 is 0. Sine 2n pi is 0. Sine of minus n pi is still 0. So let's do that. So what it means is this part that has minus pi will get 0 here. This part that has pi will get 0. The only useful guys will be the pi over 2's. Because at every single pi we have, we're going to be getting 0. So this is 2 over n pi. Now let's start. For the upper limit, what's the upper limit? This is the upper limit, right? So this upper limit, this will be sine of minus n pi over 2. Because we're going to be putting this as the upper limit. And then minus, put in the pi. When you put in this minus pi, we're going to get 0. We're going to get 0. So this is 0. So this is for this part. Then plus, for this part here, for this part, this will be sine of n pi over 2 minus sine of minus n pi over 2. Now, what did I just do? Anywhere I see x, I'm going to be putting pi over 2. So this is sine, right? So this will be sine of n pi over 2, then minus, because you must always do upper limit minus lower limit. So this is sine, then this nx here, anywhere you see n, the x, you put the minus pi. So that's how we now have minus n pi over 2. So close this guy up. And then minus sine, for this part, this will be putting x as pi, so this is n pi, which is 0. Remember I said we don't want to stress ourselves. So that's 0 minus sine n pi over 2. Okay. So let's see. So this is 2 over n pi. Now remember that in trigonometry, sine is odd. So this minus will come aside to make this very minus. This minus here will come aside to make this very minus. So that will become sine n pi over 2 for this part. The 0 is nonsense, so it's gone. Then plus, for this one, if this minus comes outside to make this other minus, that will be plus, right? So these two things will not be exactly the same, adding up themselves. So that will then be double of it. So this is 2 sine n pi over 2. So then become double of itself. Because sine n pi plus sine n pi over 2, the guys will add up to give you 2 sine n pi over 2. Now minus will give me plus sine n pi over 2. Okay. Now if you look at this, how many sine n pi over 2 would we then get? This will then become 4 sine n pi over 2. So sine n pi over 2 plus sine n pi over 2 plus sine n pi over... Sorry, let me say that again. Sine n pi over 2 plus 2 sine n pi over 2 will give us 3 sine n pi over 2. And then plus another sine n pi over 2, that will give us 4 sine n pi over 2. So this is 2 over n pi times 4 sine n pi over 2. So this is 8 over n pi into sine n pi over 2. Good. That's what we have. Now, this sine n pi over 2 has its own special value also. That's a special behavior. So what I would do, I want to leave these graphs here. There's a reason for that. So sine n pi over 2. This n, let this n be an even number. Provided n is even, this will give us 0. When n is even, this will give us 0. So sine n pi over 2 is always 0. And I believe you know why. Let us put in an even number. Let's put 2, for example. If we have sine 2 times pi over 2, 2 we cancel out 2. So sine pi is 0. So that would be 0, right? Now, if you put in another even number, you keep on getting the same 0. Then next, when n is equal to 1, that's an odd number. When n is equal to 1, sine n pi over 2 will give us 1 also. So let's try this out. Sine, when n is 1, so this is 1 times pi over 2. So this is now sine pi over 2. Sine pi over 2 is sine 90. So that's 0. Oh God, that's 1. So that will give us 1. So sine pi over 2 will give us 1. Now, do you know that in trigonometric functions, it can be cyclic, meaning the next number where this would happen, is going to be in additions of 4s. Let me explain, please. When n is equal to 1, the next time when this would be equal to 1 again is when we have n equal to 5. The next time again will be when n is equal to 9. This is because when we're dealing with our cardinal points, or should I say when we're dealing with the quadrant, let me call it the quadrant, sorry. We're dealing with quadrants. We have the first, we have the second, we have the fourth, and we have the fifth. Oh, what am I doing? This is the third, and this is fourth. So we have the first, have the second, have the third, and have the fourth. So we have 4 quadrants here. Now, if there's a position here, let me say the position here is position A. Since we have 4 here, if we're going to be taking multiples of quadrants, so we have so many quadrants, because we're not only going to be ending when n is equal to 4. So we're going to be having when n is equal to 900, because the sum is to infinity in Fourier series. So the next time when this will happen is going to be in additions of itself. I would have said multiples, but it doesn't make sense to use multiples here. We're not times, we're adding. So the next time when this would happen, since we have 4 quadrants here, the next time when this will be happening, so what would I have the next quadrant? The next quadrant would then become 5th, 6th, 7th, 8th. So if this is this, what will be similar to this will become the 5th quadrant. So just like that, what do we keep on doing? We keep on adding 4 to it, because the position will remain the same, provided you are adding 4, because we have 4 quadrants. So that's why it's like this. Then when n is equal to 3, what will happen? If we have sine 3 pi over 2, this is minus 1. Remember that pi over 2 is 90. 90 times 3 is 270. Sine 270 is minus 1. Now the next time, sine n pi over 2 will be minus 1. The next time when this would happen, it's going to become n equal to 7, n equal to 11, just like that. Because with this, there will be a repetition of what our quadrant is. Now with this, let us find our Fourier series expression. Do you know why we're going to go straight forward? I'm not going to be looking for b sub n, because this function does not imitate the sine function. There's no way sine can be present in this. There's no way it can be present. So in the next few videos, you will then see why I said so. Because I am very sure that this exactly models the cosine function. Or I can say, let me put it the other way around. The cosine function exactly models this function I have here. So in no way does this resemble this very function, which is the sine. So because it does not, there's no need for me to find b sub n, because b sub n is finding the sine component in a particular function, but there's no resemblance with this and sine. So there's no need for me to find sine, because sine will be 0. If you wish, at your own will, you can find b sub n. You see that your answer will be 0. So let's proceed. So f of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sine nx. Now this is 0, is gone. This is also 0. So the only one remaining is this. This is the only thing remaining. Now let's proceed. This will be the sum from n equal to 1 to infinity. Now a sub n, remember, oh, I kind of wiped it out. A sub n is 8 over n pi sine n pi over 2. So let me put that here. 8 over n pi sine n pi over 2. Okay. Then cosine of nx. So this is what we have. Now what is the constant term here? This is 8 over pi. 8 over pi is a constant. So let me bring that out. 8 over pi. And then the sum from n equal to 1 to infinity of 1 over n. Because if 8 goes out, there must be a 1 at the top. Because this is a fraction. So it's going to remain so. That's 1 over n. Sine n pi over 2. Cosine of nx. So if the question says in terms of n, leave your answer. This is your answer in terms of n. But let's proceed. This is 8 over pi. Now let's expand this. When n is equal to 1, this will be 1 over 1. What is sine n pi over 2 at 1? Sine n pi over 2 at 1 is 1. So everything here will just become cos x. Because even when you put 1 here, cos 1x is still the same thing as cos 1, right? Good. The next one, let n equal to 2. But at n equal to 2, whenever it's even, you get 0. So let's throw that out. The next one is when n is 3. When n is 3, we're going to be having this as minus 1. So this is minus 1. If it's 3, 1, we're going to be having minus 1 over 3 cos 3x. Let me explain. This is 1 over 3 because n is 3. So 1 over 3 times minus 1. That's minus 1 over 3. And then cos x. So the next one will be 5. Remember, you cannot do 4. Because when it's 4, it's going to be even. So 5. Now for 5 is positive, right? So this will be plus 1 over 5 cos 5x. Next one is 7. 7 is negative. So this will be minus 1 over 7 cos 7x. Sometimes you just notice that, oh, it actually follows a pattern. And just like that. So this will be the answer. So with this, we're going to end this very video. This will be the final answer to the problem. Now remember that I said that these are multiple. So there can be an equation where this is 1, 1, 1. What you basically have to do is to divide here by 2. I think I'm going to explain something like this. Because sometimes your lecturer, for those of you doing engineering maths in Uniben, the lecturers might give different students paper type having multiples of equation. So some student might receive the one that has minus 4, 4, minus 4. The Fourier series too will still be in the same, in regards to that same multiple. So I'm going to treat that so that I make comparison and then be able to give you accurate information. So with this, we're going to end this very video for now. I'll see you in the next one. Bye.